Hi, I'm Evan. We're going to take a departure from server-side stuff and go a completely other way here. We have a light, some hardware for this talk. Because Node is awesome, and it can do a lot. It's amazing at servers. It's amazing at front-end stuff. It's amazing at back-end stuff. But it can also do a lot more. It can do all sorts of fun things, that controlling lights, talking to drivers, dealing with streams of data of not HTTP, but over the network. So this talk is probably less educational and more exciting, hopefully, if I do it right. Just kind of to give you an overview of some of the crazier ideas you can do with Node and how easy it is because the ecosystem is so great. Yeah, so let's go. Because this is going to be a little weird of a talk, I made sure to make the code for it available as a GitHub link with all the code compiled at the end that we're going to go through today. So Node's great HTTP. You can make a whole server that's absurdly performant in like 5 lines. This is the basic hello world example. That's kind of the point. That's probably why you're all here. Even if you haven't used Node, like you just know that it's absurdly fast at handling web requests. But it's also good at a lot of other stuff. So like we know it's good for WebSockets, but it's good for just like regular TCP connections. Like there's a lot of video game servers written in Node. I happen to know that some of the new big MOBAs are using Node as their backend, and UDP as well, just other types of transports to send data back and forth that's not necessarily web. It's actually surprisingly good at talking to drivers. Like there's the C and the C++ add-on. So like that whole ecosystem is available to like talk to USB ports and talk to other stuff. And making those bridges is not too hard. And specifically, dealing with streams from all the above is what gets really cool. So like lots of stuff can handle HTTP requests and web requests, but very few things can handle this streaming data in like the non-blocking way. So like the golden message here is like, do whatever you want, just don't block the CPU and you'll be fine. So if your stream of data happens to come from a driver versus WebSockets, like it's cool either way, it can be handled. So really quickly, we're going to use Telnet and Twitter to turn a light on and off in this demo. Just kind of something absurd I could demo quickly to show you kind of how this stuff is easy to do. So real quick, I'm Evan. I'm the director of technology at TaskRabbit. We're hiring, talk to me later. I also run the Action Hero JS framework, which the website says it's a multi-transport API. So that's kind of a weird sentence. Like, what does that mean? So the whole point of this framework is that it abstracts various protocols into kind of a common property. So whether you're speaking web, WebSocket, socket, Telnet will do, it kind of abstracts all the connection parameters into kind of a normalized way that you can deal with it. So like, there's all these servers. They get the connection object in. And then you get this kind of nice object back, and like, okay, there's a connection from some IP address that said these params. Maybe they're get request params and then in the URL. Maybe they're something you typed on Telnet. But either way, it's available to you. And then we have a middleware stack. We have kind of a object validation stack. Then you have an action, and an action is much like a controller for us. So like, you get the params, you decide what you want to do with them. There's error handling and logging, the normal stuff, and you go back out the way. So we're going to use this here in the example to go through all our different protocols. So first we'll start with these lights. We have a desk lamp. It's plugged into a thing called a DMX dimmer pack. So this is DMX, right? DMX is actually the old 1980s protocol that was invented to control stage lighting. Like every theater and every high school theater like has these kind of lights. Every big Broadway show has these kind of lights. It's like the simplest protocol. Like there's timing, and you send like 8 bits over the wire. It's literally on and off with one wire. And then you like wait a certain amount of time and you do it again. So you can control channels basically. Like I want channel 1 to be on, channel 2 to be off, and you just loop. Sleep 20 and then do it again. So that's what we're going to kind of control with our simple USB driver. So Unix is pretty cool, just like DMX is pretty cool. And there's also great packages out there. So FTDI is, I don't remember what it stands for anymore. But it's a USB protocol to deal with these kind of devices that is really a simple Node extension on top of the C library. And it lets you do really simple stuff like search for your connected devices and connect to them. So here I'm saying require the package. I looked on my box, and the box told me these things. It speaks at a certain baud rate and speaks at a certain protocol. And I happen to know from the DMX protocol that I sleep. I send an array of how many bytes my universe is. That's a DMX turn universe. It's an array of 512 objects. It can be from 0 to 255. And then you just set the things in your array. So if I wanted to turn light, turn light 1 on, I would say 250. And then the rest of the lights be off. You just build up your array like that. And that's how you talk to it. So we have a loop, little set timeout. So we're going to sleep for 21 seconds, and we're going to send our universe down to the device. I'm going to cheat, and I'm going to turn on and just turn everything on to begin with. And every so often, I'm just going to switch, turn all the lights on and turn all the lights off. And that's all this project does. So everything in Node is has a common error and data response pattern. So pretty much every asynchronous function returns an error as the first argument, anything went wrong, and then your data is the second argument, whatever that might be. So in our world, we're asking the operating system, like, hey, do you have any of these devices? Give me them. Connect to the first one. Then every second, do that flop thing and turn the lights on and off. So I'll give this a start here. I'll just say node DMX. And hopefully if this works, we'll spit out all the devices the OS has. So we have one device with some signatures. And every second, my light will turn on and off. Every one of those dots, by the way, is that sleep loop. So sleep 21, do it again, sleep 21, do it again. So we can turn this light on and off with Node. And I think that was like 50 lines of code with a bunch of comments and spacing. So that wasn't too bad. So that's cool. So we can talk to lights, we can control lights. I went through the basics. So in Action Hero, I'm going to take this simple code, just DMX.js in the project, really simple. I'm going to shove that into an initializer. So initializers are kind of how in Action Hero you build up connections to random things. It's a little more verbose here. It's the same basic stuff, though, require FTGI. There's kind of a little more formal error handling going on here, like we should log errors if they happen and things like that. But it's the same basic stuff. There's the write loop where you sleep for a while. We have a bunch of error checking, like you shouldn't try to set the power too high or else the light bulb will explode and things like that. But otherwise, it's the exact same function. And we built up an array, a global array called API.dmx.universe. That's the same object we were messing with before, the array of all the bytes. And that's kind of set in our server. So if you turn on the server, use npm start here, it'll connect things and say, like, at some point, here we go, I found the device, I turned it on when the server booted, and everybody's happy. So in Action Hero, the whole point is about actions. So these are kind of the abstract controllers that all the different protocols can use. So we wrote a really simple one called DMX, which takes two inputs, channel and power. So I can say turn channel 1 on, turn channel 1 off, whatever it might be. We do some really stupid sanitization, like make sure they're ints, and just try to set them. So we'll start with curl. We'll use the really basic kind of web stuff. So curl localhost. Port 8080 is what we happen to be running on. And I'm going to say API DMX. Oops, sorry, 8000. All right, server's up. There we go. There we go. I guess the Wi-Fi in this network's room's a little weird. But so I say no channels, so error channels required. Channel equals 1, and power equals 0. So let's turn the light off, because we're currently on. Light goes off. So that's one of the first APIs we've written to control our light here. All right, so let's get crazier. Let's talk about Telnet. So if you are a huge nerd like I am, I know Telnet because it was how you played video games for free in the 90s. Telnet is a wire protocol. It's what Memcache speaks. It's kind of like what Redis speaks. It's a basic layer on top of TCP to have a persistent connection. You basically like send a line and you get back a line, send a line, get back a line. It's really, really dumb, really simple, been around forever. The advantages of Telnet are that your connection is persistent, and if you want to have the smallest amount of data to send, like much smaller than HTTP, because maybe you're making a video game or something, like a video streamer or something like that, you send a lot less data each request, so maybe it's valuable for you. So let's start up another demo. So Action Hero comes with a Telnet server, and you can just use Telnet if you're on OS X or a Unix derivative. Let's connect to 000 on port 5000. So I have my little welcome message here, and it says hi. So with a persistent connection, you have some extra things to think about, which are kind of fun. With HTTP, you really make a request, and you get back data, and that's kind of the end of the transaction. It's stateless. That's the whole point of the thing. With persistent connections, you have to worry about kind of things like simultaneous connections and like weird data handling stuff. But simultaneous connections is the most interesting one, because say you have something that says like, go to the database, look something up, and give it back to me, and that'll take, let's call it 100 milliseconds. You can do like 20 of those at the same time, and you have to know that like the response is from request 1, this response is from request 2. And you have to kind of limit the whole thing. Like, I don't want to overload my database by just hitting like, give me data as fast as possible and spamming the system. There's a lot kind of different things to think about there. The way Action Hero handles it, there's the notion of kind of a request counter. So if I say like param add, I want to say that I'm setting a param on my connection that I'll use later on. So I'm going to say I want channel to equal 1. Oops, I think it's add param actually, sorry. Nope. Thank you. Param add channel equals 1. There we go. So you notice that like it said OK, and this is a context is a response to something I said at some point. This is the third message I sent. This is the response back to the third message. So the clients can kind of keep straight what's going on in their ecosystem. So I'll do it again. Param add power equals, I don't know, let's say 250. Great. So now there's 2 params set on my connection. So every request I do from here on in, I'll send those params like they were GET requests or something like that. So if I say DMX, all that information was saved on my connection on the server, and all I had to say was DMX to turn the light on and off. So if I want to just change what power I want, power equals 0, I can just say DMX again, turn the light off. So you'll notice like a much smaller payload is being sent each time I do anything, but I had to have the overhead of kind of setting it ahead of time and things like that. So that's Telnet. We can do the exact same thing with WebSockets, fascinatingly enough. The same design considerations need to happen when you do WebSockets, because just like with Telnet, you can spin off like a number of requests while you're waiting for stuff to get back to you. I've actually seen I've personally broken a number of my own production systems by not remembering this could happen. Like if you request too much data at once, like you can just overload your systems, and you have to do smarter things about load balancing and kind of connection management and stuff like that as you go. So let's go through another little example. So with WebSockets, it is the easiest to do this in a browser. So let's go to a browser. So the server is also a web server, and it has a very static page, just DMX HTML. And there's an Action Hero client library you can choose to include, and you create a new object, and you set up kind of event handlers. So we're just going to use console log to make this simple and just look in the console for example here. But at the end of the day, once you're connected, you can then use the client like you would anything else and call actions and set objects and stuff like that. So let's go back here, reload. So at some point, we got a message from the server, and we connected, and everybody was happy. So the way the client library here works is you pick an action you want to say. You provide your params, so channel and power in the normal way, and you get back data, and then we're going to log it. So let's do this, missing one of the required params. So this says, oh, you forgot power. Power is a required parameter. And just like a Telnet, we're doing this message count thing, because I could be saying a number of messages at the same time. So if I'm really good at pasting really fast, you can see I turn the light on and I get the responses back as they come in, so I can know which request count was each message returning to. So same deal, I can turn the light on. We turn the light on. We can also turn the light off. Oops. 0 is a funny character, of course. You got to quote it, but it's fine. So that's a number of protocols, kind of some of the more basic ones. So let's get really crazy. Let's pretend let's use Twitter as an input to our system. So we could make another initializer. We could connect to Twitter's streaming API and pass it our keys and params and stuff and kind of get data in and just directly talk to our global object, that API, the DMX universe thing, and just control the objects that way. But there's kind of a philosophical aside, as I call it here, I guess. You could think of each tweet kind of like a connection. It's from somebody that has a unique ID, like their Twitter handle. They have a body content, which is the message. And like maybe you want to treat Twitter like a server. Maybe you want to treat that as another source of data into your ecosystem. And you want to be able to use the same kind of middleware layer and action layer that we already have built up. So maybe that's kind of a good metaphor to use here. So the last kind of, it's probably ridiculously small to see. The last kind of feature we have here is Action Hero can generate servers for you. And you get this boilerplate code. And really, you just have to handle passing payloads into this middleware helper. So I'll show you the important pieces here. We're going to use the Twitter library, by the way, which is awesome. It's super easy to use. We're going to say that like our Twitter object is a new Twitter object, and you pass in your keys and secrets like you would for any normal Twitter thing. You connect. We're going to filter for a specific hashtag. In a second, I'll show you what that all is. And we're going to do this thing that says, like, every time we get a data object from Twitter, we're going to do this add tweet handler. And we're going to use kind of Action Hero's built-ins here to build a connection that has certain properties from the tweet. So we're going to have this raw thing that's really the properties of the actual tweet, like what was the hashtag, what was Twitter's client ID for it, and stuff like that. We have no clue what their remote like port and IP address are, which are global handlers, which are normally useful, but we can just ignore those for now. And every time you build a connection, it's passed in the normal way into the Action middleware stuff, and it's happened. So if you can see on connection here, we're cheating. We're always saying the action's DMX. We don't want to have to parse Twitter messages in different languages because I'm very lazy. And we're doing what we did with Way at the beginning. We're just going to flop. So if the DMX light happens to be on, we're going to turn it off. And it happens to be off, yeah, we're just going to turn it on. Because parsing Twitter strings seemed very dangerous to do on my laptop. This seems scary. So for our last trick here, the hashtag is going to be node lights. And the server is already on. And so if you noticed here, like every time you got a message, we kind of logged the protocol. Like we had some WebSocket stuff. We had some just raw socket stuff. So as messages start coming in here, and feel free to tweet. I will tweet right now. I'll say hashtag node lights on, and I'll hit send, and it'll turn on. Hashtag node lights. Yeah, that's about right. Off. Oh no! All right, other people tweet at me. But as this happens, like we're getting an action from Twitter, and in a normal way, we're getting parameters in just like every other framework, and we can kind of handle it just as we were. So we'll just leave this going. You guys can blind the camera guy if you want to. Yeah, there we go. We got one. If I was cooler, I would have logged who sent the message. That would have been more fun. So sorry about that. I'm hiding my credentials a little lower there. But that's how we Twitter. So we can control the lights. We can control pretty much anything. The end. So I'll leave this slide up, and hopefully we can share it at the end. Here's some kind of references about this stuff. So there's a good link actually from Arduino about how the DMX protocol works. There's the Action Hero link. This project, all the example code is up there. And while the lights blink, any questions? Yeah. So yes, you could do a Pink Floyd laser show if you wanted to. At some point, I rigged up an Arduino to this kind of setup and shoved it in a Guitar Hero controller. It's very satisfying to just control lights with a guitar. I don't know why. That was really fun. This whole setup, by the way, cost, I think, $50. This little box was like 20, and then the DMX dimmer pack, which is basically a fancy power strip, an addressable power strip, was like another $20. That's awesome. Yeah, the reason I picked this hardware specifically is it was the most accessible. Like that FTDI driver runs on all systems, even Windows. And so the Node library for it is awesome. So like getting an Arduino to work is a little complicated the first time. Like how do you flash the firmware and all the other stuff? This you can just USB plug your laptop in and you're good to go. In the README, there is a note if you use Yosemite and Maverick, so you have to like unload the default OS X one. It's one command you paste in. It's in the README. But other than that, it's really easy to set up and get going. Any other questions? Cool.